Okay, you're asked to evaluate this indefinite integral using trigonometric substitution. And the primary goal of trigonometric substitution is to get rid of a square root symbol so that you can perform the integration. So when you draw the little right triangle, the idea is to look at what's under the radical to see if it's going to be a squared plus b squared equals c squared, or c squared minus one of the legs squared equals the other leg squared. So this looks like, since it's a minus, that's going to be the hypotenuse, the square root of 64, and we're going to take away this leg squared and get this other leg is the square root of 64 minus e to the 2x. And when you're using trigonometric substitution, you either want to use sine, secant, or tangent. So it looks to me like the sine of theta is e to the x over 8, or e to the x equals 8 sine theta. Take the derivative of both sides, you get e to the x dx equals 8 cosine theta d theta. And that's what we're going to replace this e to the x dx with. And over here, let's see what the radical simplifies to. Do we actually get rid of the square root symbol? So e to the 2x is the same as e to the x squared, but e to the x is 8 sine theta. So when I square that, that's what happens. Factor out a 64. Use the substitution that 1 minus sine squared is cosine squared, and there is what you end up with after the trig substitution. So here's what we're going to substitute for all these expressions. We can pull the 64 out front and figure out that we're taking the antiderivative of cosine squared theta d theta. We won't go into how you get the antiderivative of cosine squared theta, but you can look it up in a table of integrals. It's 1/2 theta plus 1/4 sine of 2 theta. I like to rewrite sine of 2 theta as 2 sine theta cosine theta. Distribute the 64, and there's what we've got. Now, how do you get rid of the thetas? Well, here's what we know. Theta is the angle that has a sine of e to the x over 8. And so far, we've got the antiderivative as 32 theta plus 32 sine theta cosine theta. Theta is the angle that has a sine of e to the x over 8, or inverse sine of e to the x over 8. That's what I replace here. And now I can look at my little right triangle to find out what the sine of the angle that has a sine of e to the x over 8 is. Well, of course, that's just e to the x over 8. But the cosine of that angle is the adjacent over hypotenuse, square root of 64 minus e to the 2x over 8. And you can do some cancellation here and end up with a 2 in the denominator. Okay, so there's your antiderivative. And here's some proof. Here's the original integrand. Here's the antiderivative, big F. And if we take the derivative of big F, we should get back to where we started. And that's what this is right here. F prime of x is the derivative of f of x. And if you go to Desmos and graph them both, see they're both enabled. They're one on top of each other. And here's a little table that kind of confirms that f prime and little f are the same function. So this must be the antiderivative. Notice I added the constant of integration here at the very end. There you go. Hope that helped. If you have any questions, post a comment.